Hello and welcome back to the lab. Today on the bench we have another unit from a viewer. This was a meter that I was asked to check in, a DM501. If you are looking at purchasing some of these TM500 meters from the lab, I would caution against grabbing this one. I know the owner of this particular meter picked it up in a bulk buy with a bunch of other modules and things like that. On the surface, it looks like it would be a great meter, but it has some design issues which make it an okay meter. I'd never call it bad by any stretch of the imagination, but accuracy suffers. So it is a precise meter to 4.5 decimal places. It is not an accurate meter to 4.5 decimal places. So to get a good piece of measurement equipment, you need both. A couple of the problems in this particular meter, there's not even going to be many capacitors that we need to address in here because it uses a high frequency switching power supply, but that's one of the design flaws that's in it, is that switching power supply. So here are our bulk caps over here, these two tantalums. That high frequency power supply is based on mains frequency. So it does not have a mains isolated power supply in it, and this mezzanine board is the integrator on this particular unit, so this whole board will pop out. But this is essentially the ADC, so it doesn't have an integrated ADC for doing the DMM measurements. Whereas, we'll grab one of my 502s off the top of the... Well, you can't really see it because it's covered up. Hang on a second. And look around the lab eventually and you'll find what you need. Here is the analog board from a DM502A that did not pass calibration and had a unobtainium capacitor that went bad. That's why it wouldn't pass. The AC wasn't alignable. So we have the ADC right here, U1205. So essentially, when we look at these two units, we have this entire mezzanine board rolled into that one chip in the 502. Now, they fixed a lot of these problems, actually all of these problems, in the DM502 or 501A. So this one also is not auto-ranging. The DM501A solves the power supply problem, solves the ADC problem, and gives you auto-ranging. So if you're looking for a 4.5-digit TM module meter, if you can catch one, the 501A will be a much better buy as long as the price is right. These meters, all of them, I've done a bunch. They typically calibrate pretty well. I very rarely have a couple that completely fail calibration and need some repairs, this being one of the only ones that's done that. And I've got 6. I've done some for other people and things like that. So pretty good repairability and track record on these meters. So not bad units to pick up. This one comes to us from the VA hospital in Big Springs, Texas. Was last calibrated in 2022. So we're going to clean up the switches and things like that, and then we're going to spot check the calibration. And since it was last calibrated in 2022, I don't think we're going to need to calibrate much on here because these components have kind of gotten to the end of their drift period. So what happens with a lot of this equipment is when they're brand new, the components are still getting burned in, things like that. References are aging, things like that. In high-end meters, like my 7500, my 7.5 digit, the references are burned in before they even see a unit. So they have a whole bunch of parts. They're baking those in, sometimes for a year or more. But they have a procedure that they know works to stabilize them. But as the units age, they actually become more and more stable. So eventually you end up just checking in the equipment. Some of the meters and things that I have in the lab, they've seen their last cal cycle. I'll spot check them on occasion, but obviously I have to send the 7500 out for calibration. But we'll but all the equipment is relatively stable at this point, as long as the environment doesn't change too much. Obviously, humidity, temperature, things like that can throw these things out of balance. But once everything stabilizes, it tends to not move much, and they're very good for a very long time. So I expect when we put power to this, which we'll do here in a minute, I'll hook up some of the references, and I don't think we're going to have too much trouble. All right, we have our test power pack, TM power pack module in, and we'll go ahead and turn some stuff on. Okay, that was kind of interesting. It stayed at overload for a little bit, and then decided to start counting things. So we're going to give this some burn-in time. Let this run up. DC 20 volts. Let's just throw on a power supply. We'll set it for 15 volts DC. 3 amps. It's not going to move much at all. 14,971. Not bad. Is very possible. I do know the Regal. It's usually off by about 3 millivolts, so not too crazy. We'll really want to check this versus the DC standard after it finishes warming up. But none of this gear's warmed up. It's been on for 30 seconds, so I expect all of this to change and some things to drift around for a little bit. So we'll wait on as I wait on the 7.5 to warm up, I'm going to get in, I'm going to service the contacts and the switches real fast, and then we will just kind of spot check the alignment. These finger switches here, you can kind of see them under the cam. This is actually a good way of how the Tektronix cam switches work. The scopes work the same way, everything works the same way, as these little bumps push the switches down onto pads that are on the board, and that's how ranges are set and everything like that. So these were in really good shape, so I just hit them with a little bit of aerosolized alcohol, clean them up, flush them out, let the contact wiping do its job, clean them up. For longevity's sake, having a good plastic safe lubricant, putting it on these teeth. I've seen some of these lubricated with lithium grease that has long since dried, things like that. It definitely changes the feel of the switches, makes them, because I've done so many restorations, I can tell the difference between a properly serviced contact switch and a non-proper, and a one that's binding, so makes them a lot more pleasant to use. I got the shield put back on here. That just kind of pops in on this particular unit like so, and goes on with 6 screws. And then we get the, we'll end up letting this warm up. So I'll get the screws zapped in, and then we'll fire it up. Okay, there shouldn't be any magic smoke problems with this one. Oh, that's acting a lot better, actually. Alrighty. Let's go ahead and hook up our 15 volts again. And we didn't even change the alignment on it, so that looks very healthy. So what we're going to do is we're going to let that run, let that sit. We'll fire up the standards here in a little bit and just kind of spot check it. Okay, to start some of the alignment process, we're just kind of spot checking. We have a short, nice heavy gauge speaker wire, both terminated into the banana plugs. We're on the 2 volt range. We're checking the integrator 0. The integrator 0 is good. Now we need to check about 1.8 volts and go from there. Okay, and using the same cable that I was measuring this on the DM501, we have 1.8 with 4 zeros on the back of it. That's plenty good for checking this meter. And we are off, actually. So that's going to need an adjustment. And it wants it to an accuracy of 1 count. So that's 1.8000. So that is not going to be sufficient. All right, this is the middle of the 10-turn potentiometer up at the top. So we're just going to get a tuning tool on that. This should also tighten up all the ranges, because all the ranges are based on this adjustment. So with this being off, everything will be off, and we're going down, so we actually got to go the other way. And this is the stability that I was talking about with the power supply and everything like that, kind of where this meter, it's jumping around a little bit at this extreme end. My source is stable, so the noise we're seeing is the meter itself. That's where we come into, this is a precise but not accurate DMM. Now, reversing polarity is pretty easy. We just pop this out, flip this over. This is also going to be off, so we are going to dial this back. I don't know if anybody's been fiddling with this. See if we can't get on that potentiometer. These are 10-turn pots. Bob Pease was not a fan of these for adjustment reasons, because if you bang on them, they like to move. This one's way off. Yeah, that was almost a complete turn off. All right, so this now agrees with my 7500. Let's check the positive polarity again, just to be safe. Looking okay. Well, I was using a function generator to check the AC output. This should be 70721, where it's 7097. So we are, this whole thing's going to need an alignment and calibration. So we'll take it from the top. Okay, so our record isn't broken yet. TM modules need repair or alignment. We'll do ohms real quick. My resistance box, which is right here, which is struggling, but I checked it on the 7500, is set to 1800. That's about as good as we're going to get it. That is a very fiddly control. And our current measurement 0 is off, so I need to adjust R50 to bring it down. I wanted to be on the plus side of 0. Now we are on the 2 milliamp range, so we're going to ask the SMU. Source current, measure voltage. So this will give us an idea of the burden voltage over the current shunt. We're going to ask the SMU for 1.8. No. We're going to give it 5 volts. We're going to current limit it at 1.8 milliamps. And we're going to hit go. And we have about 180 millivolts over the current shunt and 1.8. That looks pretty healthy. And it's just checking the validation at this point of the current sense. So we'll bump it up. That is the 20 milliamp range, so we'll go to 18 milliamps. Looks good. We'll probably go to, 180 milliamps. Oh, 180 milliamp, not amp. Don't do that. So we have switched ranges now. We're on a we're at 250 millivolts burden voltage. Let's kick it up one more. Here's the 2 amp range. I think my SMU maxes out at 2 amps, or at an amp, but let's try 2 amps and see if it'll give it to me. No, 1 amp, so we'll check it at 1. I need the high current SMU to 1 amp. And we're good at 1 amp with a half a volt burden voltage. So amp range looks good. Okay, the AC volts are off a little bit. Not awful. About as good as I can ask for out of this meter. Yeah, the 18 volt range is a little off. This should be 18,000. We need to pull some capacitance out because we're also testing this at 8 kilohertz. This is touchy. So I need to be high by about 20 to compensate for the capacitance of my tuning tool. Sure likes to dance around it, doesn't it? That's going to be about as good as we're going to get it. At this point, I need to say and have everyone be aware that these voltages are about to get spicy. One of the crazy things about doing DMM alignments and calibrations is you need to adjust the 200 and 500 volt range. So I'm going to have 200 volts AC at 8 kilohertz on this connector here. So I'm going to need to kick up the precautions a little bit. I do have an AC calibrator that can generate up to 1500 volts AC. As always, caution is necessary. These are some quite spicy voltages, so the bench is about to get a little more dangerous. And if anybody's curious, here's the amplifier down here. It is in operate. We are running it right now, and there is a giant lightning bolt over there on that connector. The connector is going up through a BNC cable, and I'm not touching anything, and I am nowhere near that thing at the moment. And definitely that lightning bolt is not to be ignored. Things are getting a little stupid. All right, we are off a little bit. I have a ceramic tuning tool right here. Let's see if I have a bigger blade. Do I have a larger? Oh yeah, larger ceramic tuning tool. These ceramic tuning tools are really nice, especially for doing AC compensation work. But if you're not careful, you can crack the ceramic off the screwdriver tip and ruin them. So always take care. Now I am being extremely careful. Where's my capacitor? There it is. That's how touchy this is. And it still dropped when I came off of it, so I'm going to need to be a little high. At least in the beginning. Come on, get out of the way so I can see the slot. There we go. No, way wrong. Come on, play nice. Sometimes it's an argument with these things. Yep, I need to be about 10 high. What that is just the capacity, because this is a air gap capacitor, so I'm pushing on the board to make sure my tool doesn't slip out. And just me pulling the tool away is causing the capacitor to flex just enough to drop that, to pull out that frequency response. That's it. We're going to leave it. That's as good as we're going to get it. Yeah, it's 180 volts. Okay. The next one I got to do is I have to do the 500 volt range. So I have to do this at is it 490? I think so. I'm going to have 490 volts on this connector, which is nuts. Okay, now we're going to do this at 480. I have turned the unit into standby, hit operate. Everything just got spicy. So we want to hit this for 480. And I really do not want to get near this cable. That's where we're going to go, right there. Okay, get the AC voltage standardizer shut off and shut down. It goes without saying, if you do not feel comfortable working on voltages of this nature, please do not duplicate anything you see in these videos. I have been doing this for a while, and I am comfortable around high voltage, but I take extreme precaution, and I'm also not verbalizing all of those precautions because I've been working with high voltage for so long. Some of it's gotten into instinct. So I'm doing things in the background, triple checking things, configuring things, making sure I'm out of the way that I may not be articulating on camera. So there's a lot of stuff going on to make working with voltages like that safe. So as always, please take extreme care. I also apologize if the noise level went up in the lab in the background. I had to turn the aircon on because of how much heat that amplifier puts out. It's kind of ridiculous. All right, thanks for joining me in the lab for this DM501 check-in. This one's going to go back to its owner, and it's ready to go. He knew the limits of the lab when he sent it in. At the moment, I do not have anything that can do AC current, although I do have a DM 500 meter in the queue that is going to require that. So we are going to be taking a look at that here shortly in the future. So if you like what you're seeing, stick around. Anybody who would like to support the lab, there's a PayPal link in the description along with the Patreon page. Patreons are about three weeks ahead in terms of videos. So as I post videos on the Patreon page, they fold into YouTube about 3 weeks later. If you want to get caught up and see what's over there, head over there. We have a couple of other Patreon perks as well, like a Stratum 1 time server that I run privately, and a few other things. Some of the 10 megahertz reference videos have more information on those in there. As always, I will see everybody in the comments in between videos, and more is always on the way.